Alright, so before we start our discussion, let us have our short opening prayer that we usually do, right? So let us pray in the name of the Father, the Son, and the Holy Spirit. Amen. Lord, we offer you everything we do today, all our works, our joys, and our sorrows. Everything will be an act of love for you. Holy Mary, Saint Joseph, Saint Joaquin, and Saint Anne, and Guardian Angel, intercede for me so that I may be deserved to be helped and saved today and always. Virgen del Pilar, pray for us. In the name of the Father, the Son, the Holy Spirit. Amen. Alright, so this video for today is intended for the continuation of the lesson that was tackled for the grades 5, no? Which was the circumference of the circle. So by this day, we are going to discuss uh, an interesting topic, which is a great factor of the totality of the geometry, no, in the world of math. All right, so by this time, I will be introducing you into some of the ideas of what would be this topic all about. But then we're going to uh, maximize our informations with how does this thing is happening, no, because you cannot just simply deal in just one information, then the latter part you don't know what are the things that you should know, uh which is in connected into this topic. All right, so for this day, no, our lesson 4 for today is about the area of the circle. I know that some of you already are aware of what is an area, no? So, but once again, no, to recall what is an area, when we are telling area, so there are two things in geometry, no? Well, four things, no, to be remembered. First is the measurements of the side of a specific shape, or what we call as perimeter or circumference. All right, so next in line is the area. Okay po, area. And the third thing is the surface area. And the last thing is volume. Now, in this part, we're going to deal with the area. Now, when we say area, there are two things that are similar to each other, which is the area and surface area. When we are telling area, it talks about the plane. Okay po? Once again, when we are talking about the area, that is dealing with plane. Okay? Now, when you are dealing in surface area, we talk about the area of a 3D object. Okay po? Again, 3D object. Now, I want you to think about of a 2D shape. Let's talk about square first. I know that we are in area of circle, no? But let's recall all the things with regards to the area, because I know that maybe some of you have lost already no, from this topic, because they most commonly students got confused on geometry, because it is a little bit hard for most, most of the students who are trying to learn this thing. So maybe it would be better if we're going to try to cope try to recall once again what is area and surface area all about. Now, so when we are saying area, once again, no, it is the measurement of the size of a flat surface, or no, or in a plane in two-dimensional. Again, plane in two-dimensional. So there are shapes that we usually see, no, most likely the polygon shapes, you know that one, right? So when we are dealing in surface area, that is, no, that is the measurement of an exposed surface in a 3D shape or in a solid shape. So After this area, we're going to talk about that solid shape. No? So, by this time, I'm going to recap once again, no, in terms of area. All right. So in area, we tend to have these basic shapes that it would be beneficial for you to recall what is area all about. No. So first and foremost, we have this square. So you just imagine this is a perfect square. All right. So this is a square, rectangle, triangle, okay, trapezoid, and a circle. So I just give you five basic shapes. So basically, that is the basic shape that you might want to know in identifying what is an area of a shape. But of course, there's a lot of things to know when you are finding the area. But in this part, I want you to deal with this part. So once again, to recall what would be the area of this shape. So when we are talking about area, we are finding the measurement, no, of the whole plane. Okay po? Or the measurement of the flat surface in a plane. Again, in a plane or in a two-dimensional. No? In a two-dimensional. So, it turns out that when you are finding an area, you are referring the inside measurement, right? Because when we are talking about perimeter or the circumference, right, we are dealing with the measurement which could be found, okay po, along the line of a shape or the outer part of the shape that makes it as a shape, right? Once again, when we are talking about lines, no, it is composed of many points. But when we are talking about area, no, because we said that perimeter are the measurements outside of the shape, for it to be a shape, no, we are getting the measurement of that outside shape of a shape. But when we are talking about area, we are dealing inside of a shape. So once again, just to recall, this will be just quick. So the formula in getting the area of square, that is s squared. Okay, s means side. Okay po. So, in rectangle, the area, in order for you to get the area or the inside measurement, no, or the the size, okay, I'm sorry, the measurement of the size of this flat surface in a plane or in a two-dimensional, no, is we base on two-dimensional. That's why we have squared. Why is it squared, Sir Jai? Because maybe you're going to ask me, because there are times when we are dealing in area. No, please remember this one. When we are dealing in area, we deal in two-dimensional. Again, two-dimensional. Okay po, dimensional. Let's say DM, but this is my personal initials now. But just to take note that when we are dealing in area, we are dealing in two-dimensional figures. Now, in two-dimensional figures, I want you to remember that we have this x-axis. I know that this might be confusing, but I'm going to make it easier. No, we have the x-axis and y-axis. So, in layman's term, we could refer that this x-axis is your horizontal lines. Okay po? Horizontal lines. So, your x-axis is your horizontal lines. And your y-axis is your vertical lines, correct? So, in two-dimensional planes or 2D figures, now we tend to seek, no, in terms of area, we tend to seek the measurement inside the two-dimensional lines or the two-dimensional lines that forms that shape. Okay po? Because in these two-dimensional lines, I know that you might going to ask me later on that when we have these two-dimensional lines, we just refer in vertical and horizontal. So Sir Jai, are you telling us that there are no such lines like diagonals. Later we're going to see, no? So, but I want you to stick in your mind, that's why it is squared. This is an exponent, correct? So it is squared because we refer with two-dimensional lines. Now, from your two-dimensional lines, the formula of your square is s squared, correct? Alright, so if it's s squared, you have this vertical line and horizontal line, correct? So same goes by. How about this side, Sir Jai? So it is just the same with your right side, because as if you will notice, you already have this vertical line. So it refers also in the top side or top part, because what you've got is the lower part, correct? So once you've got the lower part, it automatically gets the upper part as well. Okay, so once again, once you got the lower part or the horizontal lower part, it will automatically get the top part already. Now, we are done in horizontal because we have two-dimensional, correct? So in horizontal, we have also this dimension, which is the vertical, correct? So once again, once you got the one side of your dimensions, which is the right side, no? That is your right side vertical dimension. Of course, automatically, it would get the left side of your shape. So basically, you are getting the measurement of the horizontal and the vertical. So in this part, we know square, no? We know square that when we say square, all sides are equal, correct? So it seems like we tend to seek the area or the measurement inside this figure. We know that it is square, and whatever the side of whatever the measurement of one side of this shape would be automatically just the same of the other sides, correct? Right? All right, so that would basically as is as s squared. So how about for the rectangle? So in rectangle, we have this horizontal line. Okay, so we have this horizontal line, or what we know, no? We know as the length. Okay po? The formula in rectangle is the length. Okay? And for the vertical line, this is what we call as width. 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 Okay? I'm just recalling back how we're just recalling how to get the area. Now, how about for triangle? So I'm going to put all the formulas already. Now, so for triangle, we have this 1/2 times base times height. 1/2 times base times height. I'm sorry, that's BB. Alright, so that should be 1/2 times B times H. Now, how about for trapezoid? So trapezoid has base 1 plus base 2 all over 2 times height. So that is basically how to get the area of a trapezoid. So this is the thing. Before we go to the circle, here's the explanation. How did it happen? Like 1/2 for the triangle. So maybe you're thinking, sir, why is it 1/2? Why does it have base? Why does it have height? So basically, this height refers to the vertical line already. Okay? In your base refers already in your horizontal line. So, Sir Jai, why there is 1/2? So basically, if you're going to look or you're going to visualize a square, for example, this is a perfect square, all right? So let's just say this is a perfect square. And when you divide it into in a diagonal manner, no, so you could see that there are two triangles, this triangle and this triangle, correct? So it seems like you divide the square into two. That's why this this triangle is the half of a square. That's why the formula in getting the area of the triangle is 1/2 of base and height. Gets already? So that's why when we are finding the area, that's 1/2 times base times height. So here in trapezoid, we have base 1 plus base 2 divided by 2. Then we need to multiply it by the height itself. Alright, so let's deal with this one by one. So basically, there are this combination, or the final combination, composed of 1/2, the height, and the two bases. Because when we say bases, no, we have this upper part and we have this lower part. Basically, when we say base 1, or some of the textbooks or informations that you might get, B1 or base 1 refers as symbol or a variable as A, and base 2 refers to a symbol or variable as B. Now, in my case, I use base 1 and base 2 to easily identify which is a base and which are variables. Now, let's talk about the base 1. Base 1 could be found in the top part of your shape, alright? So, which is the shorter one, alright? So, how about the base 2? This is the longer part. Now, how is this area of the trapezoid could be logically explained? Why does it have two bases, or why does it have two horizontals? Correct, because when we are getting the area, we refer into horizontal and vertical. So basically, we already have this height, which is the vertical. So basically, this is the height, correct? So once again, that is the height. So why do we have base 1 and base 2? So when we have horizontal, this is let me have this one now. So let's have an example from your rectangle. Alright, so once we have a rectangle shape, let's have this rectangle shape. When we are finding for the horizontal and vertical, obviously we have this vertical side, correct? This is a vertical side. So when we are referring to horizontal side, this is the horizontal side, the upper part and the lower part. So a while ago, what I said is when you get the horizontal part of one side, automatically it would get the other side of it, correct? So when you get the horizontal line on your lower part, it will automatically get the upper part of it, or the other side of it. Why? Because they are parallel lines. We already discussed what are the types of lines. We have these parallel lines, no? We have this uh, 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 parallel lines and lines that you could see that it is continuous or it has an end, correct? Right? So also I want you to realize that when you have parallel lines, whatever your measurement in one side, automatically it will be just the same. But in the case of trapezoid, both lines are not the same. So basically, the upper part has different measurement, correct? Different measurement compared to the lower part. So let's just say this is your trapezoid. So basically, you are getting this part and this part. So it seems like you have a two triangles, and a rectangle, right? So we have the base 1 and the base 2. Alright. So once you have this one already, it automatically get the base of your triangles, of your two triangles. Basically, this is your triangles, or the base of your triangles, correct? So what is the formula of your triangle? It is 1/2, then base times height, right? Correct. So basically, when you have the bases already, you already have this 2, then base times height. Possible like that one, right? Or you could put the height on your upper part. Or, either way, yeah, you can just put h in there. But, in my case, if you will notice, we have this base on your upper side. So you need to put that part in order for you to get the whole shape. Because if you're just going to get the base of your triangle, of course, this is the area that you are just looking for. Alright. But if you get the base 1, okay po, base 1 ha, base 1, automatically it will get the base 1 or the other side of it. So automatically, it will also get the area inside your rectangle. Okay? So trapezoid is combination of a rectangular shape or a rectangular prism with uh, a combination of the triangular. Alright, so I hope that it was clear and you already recall what is area all about. So basically, again, when we say area, that is the measurement, no, of the size of the flat surface in a two-dimensional figure or in a plane. Okay? So how about for circle? So let's talk about this circle because the main topic what we have for today is the area of the circle. So we are going to focus in the area of the circle because basically once we have the circumference of the circle, we have this inclusion information which is the pi. All right. So to recap, what is the formula of the circumference of the circle? What was that? That is 2 pi r, correct? So this is the formula for the circumference of the circle, correct? 2 pi r. Now, how about for the area? How are we going to find the area or the inside part of your circle? Okay, when we say circle in 2D ha, 2D, not 3D. Don't think of a sphere. Sphere and circles are different. So later on, we're going to discuss that one. So when we talk about the 2D for your circle, we only get the inside part of your circle. Now, from the formula itself, no, the 2 pi r, there will be little bit similarities that will stay on the formula itself, but there will be uh, transformation from the formula itself so that uh, you will be familiarized. You will get this much easier because the components of the formula from your circumference is also given in the area. Alright, so let's deal already for the formula of the circle. But before that, once again, no, when we have the formula, no, we always have this square, no, as for your units, right? So when we are in area of a circle, we have pi r square. Okay. So we are not already we are already getting no we are already getting the inside part of your circle. Okay. All right. So the formula for area involves r squared. This means when we say square, no, there are two-dimensional, no. This means that the area of a circle is the number of square units in a circle. Why why did we say it's square units, no? So when we say square units, yes, Sir Jai, you just mentioned a while ago, the square or the exponent in square defines the dimensional. So when we are talking about dimensional, now I'm just going to clear this slide. All right. So when we are dealing in dimensional, we refer to the horizontal lines and the vertical lines, correct? All right, so once again, let's go back to the square. So when we have square, we are trying to get the area inside the square itself, no? Not just simply the outside and the outside horizontal and the outside vertical, but we are referring inside or the measurement inside the circle. So when we have the horizontal lines inside the square, okay, we are trying to get the measurements. So how many squares are measured inside that whole big square. Okay po? That's why we are referring to square units. Okay po? So, we are trying to find how many square units or squares inside that big square. Okay, gets? So, basically, we could simply get the concept in terms of square, rectangle, because the edges or the sides of it are simple as straight or straight lines, right? So it composed of verticals, horizontals, or let's just say diagonals for the triangles, no? But how about for circle? Because we know that circle is a circle or a curved shape, right? So in circle, we have this vertical lines as well and horizontal lines. So in order for us to find the square units, how many squares can you see inside the circle? So basically, you're going to count and simply count. But in order for us to analyze and to find in an easy manner, that's why we have that formula. Once again, the formula of it is pi r squared. Again, from the squared, that is the square units. Okay, once again, the area of the circle is the number of square units inside a circle. So the final answer in finding areas of a circle should be in always square units. So I want you to remember that it doesn't simply fall into circle. How when we are finding area, for example, if your teacher asks you what is the area of the square, then you have the formula, you were able to answer, no? Always remember to put a square unit. Okay, whatever the units, for example, millimeters, centimeters, inches, always put square. For example, inch square, meter square, centimeter square. Okay, that there should be always the unit or the square itself because we are referring for the area, and when we say area, that is the measurement, no? Measurement in, no? In the flat surface. Measurement of the size of the flat surface. All right. Okay, so to get the area of a circle, again, we need to use this formula. What is the formula? That is pi r squared. And we know that the value of pi is simple as 3.14. I know that there will be there will be a student who will be telling, sir, can we just simply put in a calculator that it should be 3.14 and so on and so on and so on, because we know that there is a specific value or a value of pi which contains a lot of decimal numbers. No? Well, I know it is true, it is a fact, but we're going to base on this general, no, general general rule when we are dealing in basics, no, basics geometric ideals in terms of pi, no, because when we have that pi, we only base on the rounded value, no, rounded value from the nearest hundredths. Again, nearest hundredths of the decimal place values. Alright, so once again, the value, in our case, no, what we are going to use for your pi is 3.14. And the R is our radius. So I hope that it was, no, it was easy for you to remember, because when we have the circumference, what is the circumference? 2 pi r. We know that we need to simply multiply the 2 to your pi, then you multiply the pi to your r, correct? So, or either vice versa, you multiply 2 by your r, then pi to your r. It could be like that, right? But in this case, you know that you have the exponent. We already discussed how to deal with the exponents, right? So what are you going to do first is to simply get the values of your pi and your radius. Okay, so there are two things that you need to remember: the pi and the radius. So Sir Jai, how are we going to deal with this exponent? So I'm going to give you a quick example without a given problem first. All right, so let's just have, for example, let's just say your radius. For example, this is your circle, and you have a radius of, let's say, 4. Okay, so basically the radius of yours is 4, and the value of your pi is simple as 3.14. 3.14. Okay, so once again, we need to do the substitution. Maybe you forgot it already. No? So when we say substitution, that is a term which is similar to the term or the word of replacement. We are going to replace the value that we have. What's the value of your pi? That is 3.14. And what's the value of your r? Based from your given, that is 4. So once you have this given, you're going to replace these values to your formula. And what's your formula? Formula is area is equal to pi r squared. So first, we're going to substitute or replace the value of your pi to 3.14. So let's have it 3.14 multiplied by r. Correct? R. What's your r? That is 4. Is that all? No, because we still have this exponent which is 2. Okay? Alright. So with that case, we can now solve this part. Alright, so how do we solve these values? Okay, so maybe you're going to think, Sir Jai, obviously we're going to multiply the 3.14 to your 4, and you just simply square it. Okay, please remember what was the last topic or the previous topics that you have encountered in mathematics. We have what we called as the PEMDAS. Don't forget the PEMDAS. When we have PEMDAS, we start with the parentheses, exponents, multiplication, division, addition, and subtraction. So from the PEMDAS itself, you need to deal at parentheses first. Can you see any parentheses? Of course, both of them are inside the parentheses. So we know that we are going to multiply them. Okay, basically we're going to multiply them. But can we directly go to multiplication? Of course not. Why? Because when we say PEMDAS, okay, these 4 last letters are the fundamental rules. So we know that we already have the parentheses. You cannot just simply direct go to the multiplication without configuring this exponent. So ask yourself, can you see any exponent from your equation? Are there? Yes, of course there is. No, so we have this squared. So what you're going to do is to square the value first before you multiply to the number beside on it. Okay, so you need to square the number 4 first. Okay, so what is the square of 4? How do we use exponents? So we know that this is the power and this is the base, correct? Uh, from your 4 squared, this is the base and this is your power, correct? So basically, it refers that you need to multiply 4 to itself. 4 times 4. How many 4 do you need to multiply? 2. Because your exponent is 2. So basically, you have 1 and 2. Okay, so 4 times 4 is, what's 4 times 4? It is 16, correct? 16. So basically, you have the 3.14 times 16. So with that said, we could now simply multiply 3.14 multiplied by 16. And what is the answer? Let's try, no? Let's try. Sige po, I'm going to erase this first. Okay. So maybe as of this moment, you could use calculators, no? In order for you to get the quickest answer as possible, but we're going to compute it in manual so that you will be practiced. So 3.14 multiplied by 16. So what was my technique? First, to deal in the first digit, 6. 6 times 4, the answer is 24. Carry 2. 6 times 1, that's the answer is 6. Plus 2, that is 8. 6 times 3, the answer is 18. Right? So basically, you just put 18. Okay, 8, 1, 1884. Alright. So basically, you also have this 1. So whatever the number you multiply to 1, you just simply copy it. No, 3, 1, 4. And with that, we could just simply add it. So 4 added to nothing, that will be simple as 4. So 8 plus 4, that is 12. 8 plus 1, it's 9, plus 1, that is 10. So, about this side, 1 plus 1, that is 2. 2 plus 3, that is 5. Alright, so with that said, we have 5024. Do you think that is the final answer? Not yet. Why? Because we need to deal with the decimal numbers. How many decimal numbers do we have? We have 2 decimal places. So, with that said, you need to put 2 decimal places to your final answer. And with that said, your decimal point should be placed in here. And we could now say that the final answer is 50.24. Alright, that is the final answer. So this is the area of the circle based from the given that I've had. Now, this is your given. Okay? So with that said, maybe you could already analyze what will happen in our uh, following examples. Okay? So here is the first example. Basically, this is the second example, but first example based from a given already. Alright, so from the problem involving areas of circle, a circular park, this in real life, okay? So a circular park has a radius of 100 meters. So if this is your circular park, that is circle, it has a radius of 100 meters. Correct. So what is the area of this circular park? So before you answer, I know you already know that you need to find the pi, you need to uh, find the radius. Please remember to put the given first. What is your given? Your given is, what is your radius? That is 100 meters. And you need to see this one, ha? The given first. Given. And what is your pi? The pi is 3.14. Automatically, you need to put that one. Okay? So, after the given, always remember, I will look on it, ha? That you need to show also the formula itself. Okay, formula itself. What's the formula? For circle, the formula is pi r squared. Again, pi r squared. Alright, so once we have this pi r squared already, and the given that you've had from the problem, now what you need to do is to simply substitute the values to your formulas, or simple as to replace the value of your r, to replace the value of your pi to your formula. Okay, so in replacing, no, or in substituting, once again, I'm going to help you. What is the value of your pi? Let's substitute it one by one. What's the value of your pi? It is 3.14, correct? So basically, you're going to substitute it in this part. Okay? You replace the value, no? Instead of writing pi, isn't it that you need to put pi? Instead of writing pi, you're going to put 3.14. That is replacing or replacement, or the term substitution. Okay, the process itself, we call it as substitution. Okay, so instead of writing it as pi, that is 3.14. How about for the next term? Oh, we're done in pi. What is the next given? We have the r. R. And what is the value of r? Instead of writing r, we need to put the value of r. And what is the value of r? That is simple as 100 meters. So basically, we're going to replace or substitute the value of r to the r itself. So instead of writing r, you need to put the 100 meters. Okay po? 100 meters. Alright, so we already incorporated the substitution. Now, let's just put the meters here. Okay? It should have meters, no? The m should be inside because it is 100 meters. All right. So in this case, we know that it is 100. Okay? Or maybe you could just simply put the m afterwards. Okay? All right. So once you have 100 in 3.14, you can now equate or solve the given equation. Now, once you have the 3.14 multiplied by 100 square, what do you need to do? You need to, do you need to multiply 3.14 to your 100 already? Not yet. Why? Because we follow the rule of PEMDAS. Okay po? PEMDAS. Alright. So once we have PEMDAS already, you need to deal with the square first. You need to square the 100. Oh, what's my technique? In terms of multiplying hundreds. For example, 100 times 100, correct? Seems like when you are multiplying these numbers, what you need to do is to know how many zeros does this number or this 100 contains. How many numbers? It contains 2, correct? So instead of having 2, you just put 2 zeros. Okay? And you just copy the 1 from your 100. Basically, as it is. So that's why we have 10,000. Okay? 10,000. Alright. So, once you have the 10,000, that's the time that you are able to multiply the 3.14 to your radius. Alright? So, if we're going to multiply the 3.14 to your 10,000, no, it would end up in 31,400 meter squared. But let's double check, ha. Let's double check so that you have the proof. You have this right answer. For example, let's have 3.14. Let's deal with this term, ha. Okay. We cannot just simply say that is the final answer. That is the final answer. You don't practice that one. Alright, so what you need to do is to put 10,000 first. Alright, 10,000 multiplied by 3.14. Not all the values should be stated directly. What should it become? Okay. Now, when you have already this one, this 3.14, no, 4 times 0, automatically it is 0. So, my number one tip, if you have this kind of sequence, how many zeros do you have? 1, 2, 3, 4. You have 4 zeros. So, what you're going to do is to put simply 40 already. Okay, that's the very first technique that you might wanna copy. Alright, so in that end, you already have 4 zeros and you multiply the 4 to the last number, which is 1. So 4 times 1, that is basically as 4. Okay, so next in line, we have 1. So again, what's the technique that I've taught is whatever the number, what's your number? It's 10,000, correct? Whatever the number that you have, when it will be multiplied to your 1, you just copy it. Okay? So, 1, 2, 3, 4, and you put the 1. Okay? Okay, next.
Next in line, we have 3 times 10,000. So you need to put 4 zeros because you already have 4 zeros, right? 4 zeros, this is 0. Then in your last number, you need to multiply 3 times 1. So 3 times 1, that is basically as 3. Alright, so in that case, you can now add already. So 0 plus 0, 0 plus 0, 0 plus 0, this is basically 0, 0, 0, 0, and 4, and 1, and 3. Okay, alright. So in that case, again, in that case, is that the final answer? Would it be our final answer already? What do you think? Do you think that will be our final answer already? Hmm, do you think so? Yeah. No, of course, because we know that we are multiplying the whole number to your decimal. You have how many decimal places? You have two decimal places. So in your answer, you need to put two decimal places, and that will be the spot where your decimal point will be placed. So therefore, your final answer is 31,400 already. But once again, don't forget the unit. What is the unit of your given? What's your given? Your R is in meters. So what you're going to do is to put the meter on your final answer. Again, your final answer is 31,400, correct? But don't forget to put the M because from your given that is M. Yes, sir. Why do we have squared? Again, what is the rule? In the first part, whenever you are solving for the area, you need to put the square into your units. And what's your unit? That is M. So that's why you need to put M squared. Okay po? Or M squared. Gets po? So we could just simply tell that the area of the park is approximately 31,400 meter square. Okay? Alright. So for the third and last example. Alright. So we have this. If the diameter of a circular board is 14 centimeter, find the area, or what is the area of this circular board. Alright, so I know that the given is diameter. The first step is to put all the given, correct? Diameter in the pi. Sir Jai, why do you need to put diameter? Why is it D? Isn't it that we should put R? Because in the formula itself, we only have one formula, which is R, correct? So in this case, what we need to do, no? What we need to do is to simply transpose the diameter to radius. You need to convert because we know that diameter diameter is composed of two radius. Okay, right? But in your formula, you only need one radius. So what you're going to do in your diameter, you're going to half, or you're going to get the half of your diameter in order for you to get the one part of the radius, or the one part of the diameter, knowing that you have two radius. Okay, so in that case, you need to divide the diameter by 2, right? Because if this is your diameter, for example, this is your circle, and this is your diameter. Let's say, no, that is your, this is your diameter, and you have two radius. This is your radius, correct? This is your radius, and this whole is your diameter. This is your diameter. This is your radius. So in that sense, in order for you to get the radius, one radius only, you need to find the half of the diameter, and this is the half of the diameter, correct? Alright, so in that case, what is the value of your diameter? That is 14. Okay po, 14. And the half, 14 divided by 2, what is the value when you divide 14 by 2? That is 7. And basically, the value of your R is equals to 7. Okay? Okay, so you still have pi, no? What is the value of your pi? We know that it is 3.5. 40. Okay, so that is set already. We know that we have the values already. No? So you have the R and the pi. Pi is 3.40. Okay, so in that case, what we need to do, we need to put the given. We already have the given. Next, we need to put the formula, that is A is equal to area ha. Area of the circle is equal to pi r squared. Okay po? That is the formula of the circle. Okay, so with that case, the next thing to do is to substitute the value, right? So the value of your pi, which is 3.14. Once we have substituted already the pi, and for your radius, which is 7, you can now solve for these givens or for this equation. But when we are solving, once again, no, the rule of the PEMDAS, we know that we have parentheses and exponent. So therefore, you need to find the value of your exponent for your 7, correct? Because you have 7 squared. So in that case, you need to find the value of 7 squared. What is 7 squared? So when we are finding the value of 7 squared, that is transposed uh, in a uh, values of 7 times 7, and that would be 49. Okay po? 7 times 7, that is 49. And with that said, once you have the value of your 7 squared, okay, you can now multiply 3.14 by your 49. And what is the value of 3.14 by 49? 3.14 times 49. 9 times 4, the answer is 36. 9 times 1, the answer is 9 plus 3, the answer is 12. 9 times 3, the answer is 27 plus 1, it's 28. About for 4, 4 times 1, the answer is 16. 4 times 4, the answer is 16. Carry 1. 4 times 1, the answer is 4. Plus 1, the answer is 5. How about for 4 times 3? We know that when you multiply 4 times 3, the answer is 12. In that sense, you could now simply add these terms. So 6 added by nothing, that is simple as 6. You just bring down, no? So 2 plus 6, the answer is 8. How about for 8 plus 5? 8 plus 5, the answer is 13. 2 plus 2, the answer is 5 plus 1. That is your 1, no? 1, that is simple as 5. And you still have 1, so you just bring down that one. Okay? So is this your final answer? Not yet, because 3.14 is in decimal form. So you need to count how many decimal places. You have 2 decimal places. So you need to put 2 decimal places as well to your final answer. And that is 153.86. Is that your final answer? Not yet, because you need to put the unit. And what is the unit? Based from your given, that is in centimeter. So your unit is centimeter. So you need to put centimeter plus the exponent squared. Sir, why do we need to put square there? Again, no, when we are finding the area, once you have the final answer, you need to put the unit squared. Again, unit. I'm going to erase this one. Once you have the final answer, what's your final answer? This is your final answer. Once you have the final answer, once area is the one that we are finding, no, you need to put the unit squared. What's your unit? It is centimeter, then squared. Squared. Okay po? So, we could now tell that the area of the board or the circular board is approximately at 153.86 centimeter square. Alright, so with that said, I hope that you learned something with our topic for this area of circle, and I hope that you will be still on touch for the following topic, which is the volume already. Alright, so I hope that for this time, you enjoy and you've learned something with regards to the area, not just with the circle, but also for the past previous
lessons that you've had in your past grade levels, which are the differentials. All right. So with that said, if you like this video, please hit that like button, and if you want to subscribe, then you subscribe. All right. So with that said, thank you, and watch for my following videos. Thank you and God bless. Bye.